Hi guys, I'm back with another. This is my architecture video review kind of thing, where I'm gonna talk about what they are talking about, if they're missing anything, or is there a better alternative to it. Uh, so let's see what the Accenture has to talk about NLP and graph databases. So graph databases is actually exciting for me because there are so few use cases, and when those use cases, like we develop use graph database to develop a solution for those kind of use cases, it's actually really helpful for some of the scenarios. So let's see what they have to talk about it.
Hi, I'm Adrian and I am here with Charles from Accenture. Today we're talking about knowledge management in the oil and gas industry. Charles, can you tell me what problems Accenture has solved for customers in the oil and gas industry?
So clients tell us they are missing opportunity to buy raw oil due to the lack of accurate or timely information. And that costs them millions of dollars a year.
That sounds like an expensive problem. How does technology help here?
So the objective is to ingest documents coming from multiple sources in the client side. It could be report of extraction, it could be process reporting, it could be many different things, even internal communications. So we're extracting from the existing system of the client those information and ingesting it to our system.
So if he's extracting and ingesting to the system, then he must be storing it to his S3. And I think he's missing S3, but I think so. What I feel is he's getting the data object storages like records and reports, and then storing it in S3 and then using Lambda to process it. So I think so he's missing the S3.
So after that, we will need to create a sort of representation of our knowledge to index the documents. And after that, the third step will be to retrieve the information. So it's a three-step process. It is an ingestion process, it is a knowledge representation process, and it is a retrieval process. Both the ingestion and the retrieval have common solution. So we have been putting a lot of time and effort on specifically on the knowledge representation aspect.
Okay, so how do the services that are here on the board help you with that?
So again, at the beginning, we have documents coming in multiple formats to our system. So they go through our Lambda. The Lambda will work as a sort of orchestrator between the different services and create also some logic on top of it. So first, we have been training ahead of having the model, the system operational. We have been training our SageMaker instances to do some tasks that are really specific to the oil and gas. We have been training models specifically for our client problems. So it could be some document classification, it could be some key fact extractions, it could be multiple things. So we have been training the model first, and then after, the Lambda will be consuming. So when an information is coming to the system, the Lambda will send the information, the raw data, to the SageMaker, to the model that have been trained, in order to extract again some information. Type of information, key facts of the document, things like that. Then the Lambda receive the information from the SageMaker, and then will call the comprehend as a component. The comprehend is really the natural language processing component of AWS. This one goes more at the sentence level to try to analyze the structure of a sentence. So for example, it does some name entity recognition or part of speech tagging, things like that. And again, it's important because once I've extracted the facts, I want to understand the structure of my facts. From there, I can start saving my data into my knowledge graph for future retrieval. And
Just to let you know, guys, like what is knowledge graph? Knowledge graph is just like a graph representation of an entity. So let's suppose you're talking about Singh over here. So Singh is gonna be in the middle, and it's gonna have entities connected, like features connected to it, which is like Singh is a YouTuber, he's a blogger, he has an Instagram account, he's on Twitter. So and once you click on, let's suppose you click on Twitter, and it's gonna expand like what all tweets I made, and then you click on one of the tweets, then it's gonna tell like how many likes I got. And so it's actually a very good representation when it comes to taking decisions in sales, in marketing, or in business, any kind of. That's super nice.
for creating my representation.
Okay. What's the reason that you use a knowledge graph here with Amazon Neptune?
We use a knowledge graph for a few reasons, but the first one is obviously it's a database, so it helps us to store and to persist data. But on top of that, a fundamental difference between a knowledge graph and a traditional database, really SQL database, is that it enables us to have a much more dynamic and flexible structure where SQL structure have to be predetermined at the beginning of the project. So it evolves through times with new information coming in. And that's where that's a fundamental aspect of why we picked a database, knowledge graph database.
Okay, so this flexible and evolving structure, can you perhaps illustrate that with an example?
Yes, so we call the different type of oil crude. So I ingested the first document, and the document is about a crude of type A. Crude A, from the document, I'm able to identify that it has a density and a sulfur level. Then, at a later stage, I ingest another document regarding a crude B. This crude B has more information. It has a density, it has a sulfur level, but this time it has a risk associated with it. So I can add to that relationship to my object. That's one very important fact. On top of that, I'm able to calculate, to compute on top of my data some interesting facts. In this context, I'm able to see that, well, if my crude B has a very similar density and sulfur than my crude A, but the crude B also has this, which is a risk associated with the processing of the crude, it means that there is a very high chance, there's a probability that there is also, that risk is also associated with my crude A. So that's one of those elements, the dynamism and the flexibility of those databases, plus the computation part.
That sounds really powerful. Now, I noticed that you also have Elasticsearch here on the board. If I have this powerful knowledge graph, what's the reason that I still need Elasticsearch?
So again, the Lambda, at the same time it will trigger this first process, will also send the raw information to the Elasticsearch to be indexed. Why? Because the knowledge graph represents a series or a set of concepts that are related with each other. But potentially we would be missing information if we're not having another way to treat the information. So here it's structured raw data. So we go from unstructured to structure. But sometimes there is some piece of information that are still very important that are not meeting this structure. So in this context, Elasticsearch makes sure that we are not missing this information. So if the user type a free text query, we are able to address, even if it's not into our Neptune knowledge graph, we are still able to address it through the Elasticsearch and to retrieve the information.
That's really interesting. Thank you for sharing this architecture.
Yeah, that's pretty cool. That what he's talking about is like, if let's suppose coder Singh lives in America, and that is not part of the knowledge graph. So it's the only part of the knowledge graph was the things which I mentioned, like Twitter, YouTube, and blog. But but there's information about coders saying that, let's suppose if I've written an essay and uploaded a doc file, and in S3, and S3 triggers an Lambda function, and it gets all the information in the S3 file and process it and put it in the Elasticsearch. So I can have a full text search on Elasticsearch, and I can search for where coder Singh lives, or like address of coder Singh, something like that. I have a query, and I can write, and I can search the entire text and show them the results. So that's pretty cool. They're actually storing the raw data in Elasticsearch in text format, and I think so they're very text heavy. That's why Elasticsearch is the best solution for them. So thank you so much, guys, for watching this with me and listening to my take on it. And if you really like the video, then give me a thumbs up, like my video, and subscribe my channel. It really motivates me to make new content for you guys. Thank you so much.